So over here question given is 48 in which 50 ml of H2 gas diffuses through a small hole from a vessel in 20 minutes. So this is my say T1 and this is 50 ml. So 50 ml by say 22400 is the number of moles of hydrogen, and this one let's convert it into N2, which is the number of moles of oxygen. So we have to find out the time taken by 40 ml of oxygen to diffuse under the similar condition will be. So this is time T2 we have to find out. So what is rate? So rate 1 be the diffusion for the diffusion of H2 gas and R2 for the diffusion of the oxygen gas. So this will be becoming M2 by M1 according to Graham's law of diffusion, and that we can say to be as equal to molecular weight of oxygen is for 32 and that of hydrogen is 2, or that is going to be 16 by 1. Now that is equal to 4. That being the case, we have we have N1 by T1 into T2 by N2, wherein obviously this is going to be equal to N1 is what, 50 by N2 is 40 into 20 minutes for T1. So my T2 is, so this is how things are, and that is equal to, I know, as 4. Okay, so therefore calculating for T2 we can say it is going to be 4 into 40 into 20 by 50. Okay, so this one goes that way and that one is okay 4. So 16 into 4 is 64 minutes. So my answer over here is going to be this one. Again, what will be the slope of the plot of log P versus V for a reversible adiabatic expansion? So for a reversible adiabatic expansion, we know PV gamma equal to constant. So taking logarithm on both sides, we have log P, okay, log V gamma log K, or we can write log P gamma log V log K, or we can write this in the form of a straight equation of straight line as in minus log V gamma log V plus log K. Now comparing this with y equal to mx plus c, where this is y axis, this is x axis. What is the slope? We can see it is minus gamma. So answer over here is going to be minus gamma. Latent heat of vaporization of Br2 59 degree Kelvin at 1 atm pressure is this much. So this is my, what should I say? This is my delta H. So delta is equal to delta U plus delta N RT. What is delta N? We know Br2 is liquid going to Br2 gas. Change of number of moles is 1, because for this we have to take as to be 0. So then we will have U equal to 29.2 kilojoule. So obviously we have to write this. Okay, let's keep it in kilojoule only. And this is minus RT. So R is what? 8.314 into 10 to the power minus 3. Okay, fine. Into what? 59 and 273. So 59 plus 273 is what? This is 12 carry 1. That is going to be 13 carry 1. So 332. So 332. Okay, so let's do the sum and find out what it is. So if we calculate this part, what we are going to get is 8 point, sorry, 8 okay, into 332, right? So that is 2.76. All right, minus 29.2. So it is coming out to be 26.439, around this much. So I will say answer over here is this one. 51 ratio of the specific heat of gases at constant pressure and constant volume. So this one, so it is diatomic, they are saying. N2 is diatomic. So for a diatomic, this is 7 by 2 R, and this is 5 by 2 R. So Cp by Cv is gamma. So we will say 7 by 2 into 2 by 5. This and that cancelled. So it is basically 7 divided by 5. So that is 1.4. So answer over here is, we will say this one. At the total heat content for system at a constant pressure is known as, obviously the answer over here is going to be enthalpy. Okay.